right. Well, good afternoon, good evening, good day, everyone. So, thank you for joining this INCOSE Transportation Working Group webinar in partnership with the Railway Interest Group in the UK and also APTA, American Public Transportation Association, the Systems Engineering Subcommittee joint webinar. We have this every month, and this month we continue our sustainability in systems engineering is a part 3. We have 2 of these before, and yeah, I'll tell you in a minute where you can review those. But today, we're very honored to have MBTA in Boston. Well, we talked about their bus electrification efforts on the facilities and fleet side. So yeah, before we go into the webinar, we have a YouTube INCOSE TWG channel. I think also there will be some changes on that one because now YouTube can allow me to add, just do it like a handle, like Twitter style. So that to be followed, but as a channel, if you haven't subscribed, use your phone to scan the QR code right now and bring it to the page and hit the subscribe button. Also, we have the link in the page and also a group that we haven't been updated for a while, so I need to work on that as well. And also, as I mentioned, is a collaboration between the APTA System Engineering Subcommittee, INCOSE TWG, and INCOSE UK Railway Interest Group. As always, I'll let Dale to introduce the APTA SE and the INCOSE TWG to you all. Dale.
Oh, yeah, thanks, Hoki. Just a real quick, if anybody did get the advertisement for this session from their APTA, from the APTA site, if you could just pop it. Yeah, if you could just pop that in the chat somewhere. It's just kind of a quick V&V exercise here. I'm not sure that the APTA stuff is making it out every month. So I just want to make sure that something is getting out to the APTA membership on this. So if you did hear about this from APTA, you probably also, there's not a lot of overlapping members, of course. You probably also heard about it from INCOSE, but I'm just interested in the APTA to see if we got folks that are getting it from the APTA side. And yeah, the collaboration between the SE subcommittee at APTA, American Passenger Transportation Association, and of course INCOSE Transportation Working Group is coming due for renewal. So we're going to renew that hopefully by the end of the year between those organizations so we can continue collaborating together like this. We do have a work product that we're looking at, which is the Systems Lifecycle Engineering standard. It would be an APTA standard. It'd be actually a joint. We have to raise the paperwork within INCOSE at TechOps to make it official, but it'll be a jointly reviewed and authored standard. So that's about it for now. Are you going to talk about IW, Hoki, or?
We can talk about it next month.
Yeah, okay. We'll talk about it next month. Okay, sounds good. All right. I'll stop so we can carry on with the main event then.
Yeah, thank you. And also, Matt, yeah, you want to say a few words about the UK Railway Interest Group? Or if Matt, is Matt here?
I think so. He was.
Matt couldn't make it. He couldn't stay on, he said. So I don't know if you want me or Mike to say something.
Yeah, sure.
Mike, do you want me to take this one or?
Yeah. Oh, yeah, go ahead.
Yeah. Hi, everyone. Sorry. Yeah. For those who don't know me, I'm Carl King here in the UK. I'm one of the members of the Railway Working Group, Railway Interest Group over here, along with Mike. Thank you all for joining. And we hopefully will be continuing to do these sessions, and we look forward to seeing the presentation today. Thank you.
All right, thank you, Carl. All right, well, we introduce you to today's speaker. So we have Alexandra, but I forgot how do you pronounce your last name. So help me out, Alexandra.
Sure. Should I just go ahead?
Yeah, you can. Yeah, you can talk about. Yeah, well, I was going to introduce you, but yeah, you can also.
Oh, my last name is
introduce
Markiewicz.
yourself if you like.
You're. I can switch over to the presentation whenever you're ready.
Oh, okay. Yeah, sounds good. I would just say a few quick words. So, as manager of a bus facility modernization program at the MBTA, Alexandra focuses on developing a strategy for delivering new modern MBTA bus maintenance facilities to support the agency's transition to battery electric buses. At the MBTA, Alexandra has previously led a planning efforts service improvements and multimodal access to transit in the Boston region. Prior to her work for the MBTA, she focuses on national and international transportation research projects at the US DOT Work Center. Alexandra holds a Bachelor's of Arts in History from University of Chicago and a Master of Urban Planning from University of Michigan. So let me unshare my screen. Okay, stop share and Alexandra, go ahead.
Awesome. Thank you so much for the introduction. And let me make sure this works.
Yes, I can see
Just
it.
want to put it in the full viewing mode. Can folks see the screen?
Yes, if
Yeah,
you
it's
can go
good.
full screen, that would be.
I'm trying to, there we go. Okay.
Right.
All good?
All yours. Yep.
Okay, awesome. Thank you, Hoki. So as you heard, I'm not an engineer at all, but I really appreciate the invitation to come speak to this group. I'm going to speak about our transition to battery electric buses at the Massachusetts Bay Transportation Authority, which serves Boston and other communities in Eastern Massachusetts. My job's focused on the facility and infrastructure side of bus electrification rather than the vehicles, so I'll speak a little more on that. And yeah, just excited to dive in. Okay, so at the MBTA, we have developed a combined approach to meet our bus fleet and facilities need, which we've looked at together due to the integrated nature of these assets of the fleet side and the facilities where we store and maintain them. We have 4 goals. We want to convert all 1,100 buses to zero emissions. And we also want to employ a strategy that ensures fleet reliability for our riders, better working conditions for our staff, and an ability to expand our service to meet what we hope will be growing demand for transit as the Commonwealth decarbonizes. Unlike other agencies in the US, we did not at the start of this process actually have a state imposed specific target for electrification, but rather the state a couple of years ago set targets across all sectors of 50% emissions reduction by 2030 and net zero by 2050. We internally developed a plan that was aggressive, but we felt like achievable to transition by 2040 through building out new facilities one at a time, equipped with charging equipment, and phase in those vehicles over time on a rolling basis, as you can see on the graph here. Since we actually developed that plan, the state did impose a target requirement for us specifically to have 50% fleet electrified by 2030 and full fleet electrification, I think by 2040 or I think 2040. But fortunately that aligned with our plan. So we know it's really important to keep the average age of your fleet low to help service reliability, but evaluations over the past decade have also revealed that the state of the facilities where we maintain our fleet are in disrepair, and none of them are really equipped to deploy battery electric buses at scale. Here are some images of the existing facilities. And most of these facilities were built in the 1970s or earlier, a number of them in the first half of the 20th century. They're not modern in terms of the amount of space to store buses, to do work on them. And they're certainly don't have a ton of space to install charging equipment. We do have 5 60-foot battery electric buses that are operating out of our newer facility, but you can imagine that installing dispensers at scale at some of these older facilities would be a big challenge. So before getting into the plan for building new facilities, I wanted to talk a little bit about the strategy, how we're thinking about our strategy for electrifying the fleet. We decided that we want to start by focusing on depot-based charging using longer range, higher capacity batteries, since we're replacing our facilities anyway due to their poor condition and insufficient working condition for our staff. And by doing it this way, we'll also be able to minimize the impacts to our schedules and layover times. Whereas if we went with more of an en route charging, kind of solely relying on en route charging, we would certainly have to change the way that we schedule our service, and that would have a bigger operational impact from the get-go. This also just reduces the number of changes we're taking on at one time in terms of like not only asking our maintenance folks to do things differently, but also asking our bus operations folks to do things differently. So when we use the operational model, used an operational modeling to simulate service for all of the routes for the priority facilities, we identified that we would need to use auxiliary heaters on the coldest days to meet the range requirements for some of our longer blocks. And the graphs here illustrate the before and after of that, where the yellow, where you see it moving from green to yellow is where we expect that the battery capacity would run out and not meet the needs of a block. Each horizontal line here is a block of service. And so we see that employing diesel heaters on those cold days could have would have a huge impact on our ability to not have to rework all of our schedules to meet those needs. In the longer term though, we'd like to not use diesel auxiliary heaters, and instead have en route charging fill that gap to lengthen the range and meet some of the needs for our longer blocks. And in talking to a lot of other agencies, we found that this focus on the depots and initially using auxiliary heaters is really consistent with the approach that other agencies are taking, particularly in cold climates. And some folks who are who might have started with en route charging are finding that those projects are kind of bigger capital projects than they expected, and that's you know, posing some challenges for deploying those at scale. Do want to give a shout out though to a number of folks on this call that are supporting us and thinking about our long-term en route charging needs. So just I noticed there's a bunch of folks here, so thanks. All right, so getting into our plan for replacing the outdated facilities, which we're pairing with the electrification of the fleet. With the opening of each new facility, it would be BEB ready. It would have all of the charging equipment that we'd need for battery electric buses, and we'd plan to fill the new facilities with new battery electric buses, which kind of gets to that fleet electrification by 2040. And in order to do that, we basically need to build a new facility every 2 to 3 years between now and then, and that represents about $4 billion in investment, especially when accounting for kind of total project costs, land, charging infrastructure, etc. As this program is getting underway, we plan to procure both hybrid buses and battery electric buses over the next 5 years, filling the new facilities that open with battery electric buses, but still replacing older fleet at other facilities with newer hybrids in order to make sure we're maintaining that low average fleet age so that we're not sacrificing service reliability for the sake of this transition. Our BEB RFP is currently out on the street, and we anticipate awarding a contract this winter. The way we determined how to order the upgrades, or rather rebuilds of the facility, was based on a number of factors. We wanted to look at ridership and equity. Where are the facilities that routes come out of that serve low-income households, people of color, that serve the most riders? We also needed to match our sequencing with the fleet replacement needs, particularly for like boutique fleets that have really particular needs that we don't want to get locked into kind of buying a new set of. And then thinking about just logistically which sites we needed to rebuild in place versus which ones we could move to a new site, since rebuilding in place is more complicated and relies on having a little bit more flex and swing space in our storage network. So I'm going to talk about the first 3 projects. And I'm going to actually focus on a challenge that a different challenge we're facing for each one, which I hope gets to some of kind of the systems engineering thinking of like how we're kind of tackling, like whack-a-mole style, tackling these challenges as they come up. But just a kind of target of where we're going with those first 3 facilities. The goal is that by 2028, we'd have 3 new facilities that are all electric. That would represent 30% of our fleet. And the map on the left shows kind of where those routes are in relation to the rest of the routes, which are in gray, and the electrified routes would be in green. Okay, so the first facility project is actually unique because it's not what I've been talking about, replacing an entire facility. It is just a retrofit where we're installing charging equipment at our smallest facility so we can retire an aging trolley bus fleet that serves just 2 routes in our system. We had to bring these buses out of service, the trolley buses, anyway, because there are roadway projects in the areas where they run, and we couldn't run those buses on catenary during the roadway projects. So we found this would be a really good opportunity for a smaller scale deployment of battery electric buses. And we anticipate opening this facility in 2024. But as we're moving through the design of this retrofit, we're running into some unexpected and interesting challenges. So first, in part due to a lot of the media attention given to battery bus fires, we're finding that there's increased scrutiny from the fire department, the building inspector, and pretty much everyone on how we are accounting for fire suppression with this type of project. And that's particularly tough when we're dealing with an older facility that you can see in the image here. It was built, initially, I think, for streetcars and an outdoor storage situation. So we don't ever want a fire to occur on a bus, but if it does occur, we really want to mitigate the spread of the fire to other buses. And so on the one hand, outdoor storage is better for fire risk because you're not putting an occupiable building at risk, and you don't need mechanical ventilation. But on the other hand, outdoor storage doesn't allow you to install like automatic sprinklers like you could indoors. And we're finding you really would need to rely on like a dry type option, like a dry deluge system, where you would have open sprinkler heads that are supplied from, the water is supplied from the fire department when the fire department arrives and hooks into it, which means you have a pretty, you have a delta of time between when a fire might begin and have time to spread and when the fire department arrives and can make use of this type of system. With indoor facilities, you have the opportunity to have more like an automatic sprinkler system and can put water on a fire as soon as it's activated. And you can also upsize that sprinkler system to have a higher density to put more water in the fire more quickly and reduce the risk of spread. So we're really kind of like contemplating how do we approach this question with outdoor storage, and also how do we approach this question with an indoor maintenance facility that's an older building that we'd really need to kind of think about retrofitting. So this question of fire suppression is actually a big issue for all bus electrification projects, whether it's new construction or a retrofit, in particular because what we found is the code doesn't have specific requirements for storage of battery buses. But we are seeing that with like outdoor storage and with retrofit, it's particularly challenging to figure out the right solution. And it does also have the potential to trigger additional work on an older building. If you're going to add a sprinkler system or ventilation, say, you might be triggering other work just to bring the building up to code, which might all be really good projects, but are probably not going to be related to the initial goal, which was just to install charging equipment. And so working through this design effort, we're really underscoring that we're happy with our decision that moving forward, we're going to build new facilities, given the age and condition of our existing really old facilities. So for the first full new facility replacement, we're going to build it in Quincy, which is south of Boston, and it's a new all-indoor fully electric facility that will replace a facility that was more than 100 years old. And due to ceiling height in that old facility, we can only store our oldest diesel buses there. This project will electrify 19 routes that serve Quincy and the surrounding communities, including other communities and neighborhoods in Boston, southern Boston. And right now we're completing, or actually we've completed an early construction package to demolish a Lowe's home improvement that was on that building site. But we ran into a delay, a challenge with the start of the full construction package when the bids came in last spring and they were significantly over budget, which is an issue that I'm sure a lot of us are facing with construction projects or any sort of project with the challenges with inflation and supply chain. So right now we're reevaluating the construction documents to identify scope modifications to reduce costs while maintaining the core functionality of the project, and we're re-procuring it using a different method. We had been doing design bid build. Now we're trying to bring a CM on board and use a CMA risk approach. So our big challenge here was, how do you VE a project when it's 100% designed? Not fun, not something any architect or engineer or designer wants to do, but we really knew that we had to do it because inflation's not going away. So one of the areas we identified was a great opportunity to reduce costs is by updating our approach to how we're charging the buses. Originally, we assumed we would need 60 chargers and for a fleet of 120 buses, and that each charger would have 2 dispensers. And this seemed reasonable back in 2020 when we were developing the schematic design for the facility, given where the industry was at the time. But in the 2 years since, there's been a multitude of new options for charging, and 3-to-1 ratio of dispenser to charger is much more widely available. And there's other options for larger chargers to feed up to 10 or possibly even more, I don't even know, buses. It seems to be changing kind of every month. But these would require a totally different approach to space planning and layout. And that would, definitely be a bigger departure from what we were originally designed. So we decided to change the layout of the facility and specify just a 3-to-1 ratio rather than a 2-to-1 ratio, which would cut the number of chargers by a third, which certainly can reduce costs. And we also actually further are reducing the number of chargers to meet our current fleet, which is actually just 90 buses, not 120. We had accounted for the expanded capacity for kind of more flexibility down the road, but we don't need it today. And so just starting with a smaller number of chargers gives us kind of flexibility down the road to test out something different when we do need those chargers. So while the previous project we talked about in North Cambridge showed some of the challenges with retrofits, this process really underscores how hard it is to tackle building a new huge building and outfitting of a charging infrastructure in one project, because we need to make design decisions so far in advance of when we'd actually use the equipment. And we're dealing with a technology that's changing extremely rapidly. That's, certainly posing a challenge. We might consider kind of approaching it differently for future projects, but that has its own challenges with coordination. So we're still kind of evaluating that. Okay, so and I hope I'm doing okay on time. I'm almost done. For the last project I'll talk about is our second full facility replacement, and that's at Arbor Way, which is located in Southwest Boston at the end of our Orange Line for anyone who's familiar. There we're building a new all indoor 2-level facility for 200 buses. And it's going to be placed adjacent to our existing facility where there's green here. It's only for 118 compressed natural gas buses. Once complete, the 8 acres where our existing facility occupies will be transferred to the city of Boston for development, likely for affordable housing. And that's conveniently located next to rapid transit and a number of bus routes and a lively neighborhood. So it's a great transit-oriented development. The existing facility is really woefully inadequate. It was initially constructed as a temporary facility 20 years ago, which temporary, but it houses, and it houses an exclusive compressed natural gas fleet, which is due to retire starting in 2028. So we really want to make sure the new facility is in place in advance of needing to start replacing that fleet so we can replace it with electric buses instead of doubling down on another round of CNGs. Since we're expanding the facility to house 200 buses, this project will be able to electrify more routes and actually electrify 40% of the local buses in Boston, many of which serve low-income communities. And we're building it to house both 40-foot and 60-foot buses, which will allow us to upgrade some of our crowded routes to 60-footers. We're working through the preliminary design now and targeting construction to start in 2024. So the challenge I'll talk about here is cost and scope. So since we've had this experience with Quincy where we're running into unexpected delays due to the bids coming in significantly older, we wanted to make sure we were really tackling scope and cost at the beginning, very intentionally at the beginning, to make sure we set the project up for success to keep on schedule and on budget. We spent several months looking at what our peers have done with their new facilities, gathering information on their designs and layouts and building costs, and having conversations with some of them to get ideas on what we could potentially do differently and more efficiently while maintaining functionality. And I really like to think of this effort as pulling on 2 levers. One is just the pure size of a building, and making sure that we need every square foot that we've programmed in, because additional square feet come at a cost in terms of both land, which is scarce, and construction building dollars. And then the second is looking at the cost per square foot and identifying with the architects and engineers, how we can reduce cost per square foot, first get the number of square feet right, and then reduce cost per square foot using more efficient materials or other approaches. And so we spent a lot of time with our building end users, like bus operations and maintenance, reviewing in detail the program to make sure we really right-sized all the spaces and we identified efficiencies where possible. And it was really critical we got buy-in on anything we were proposing to change, because we need to make sure the building works. Then we worked with the design team on strategies to kind of optimize cost per square foot, looking at how we can what we can do differently from like a building systems perspective, et cetera. And then we even took a trip to New York to see their newish multi-level facility, 3-level facility that's in the picture here, that was built in 2015. Manhattan space is truly at a premium, so we were able to pick up some great ideas there. And this process is really underscored that in a world of both finite operating budget and capital budget resources, and in a place like Boston where land is scarce, we need to assess trade-offs and design alternatives from a cost perspective as early as possible if we want to meet our schedule. So overarching kind of next steps, I guess I'm talking a lot about challenges, but hopefully they're interesting. We are really excited about this plan, and I guess I hope I've highlighted by talking about these 3 projects and some of the issues that have come up that we are in a place where we're kind of constantly addressing new issues that crop up and potential roadblocks. And it's interesting but challenging to balance kind of being flexible and being able to pivot and go in new directions when a new challenge occurs, but also kind of trying to move these large, slow and steady type projects forward. I think as an urban planner, I do like that tension, but I do see how, particularly when you're designing these large facilities, that can be very, that can be very unusual. So looking ahead, though, I wanted to note a few of the roadblocks that we see might be coming down the line. First, the construction industry is really plagued with these supply chain challenges, and we've heard about delays for transformers. I'm sure everyone here has heard about delays for transformers in particular, and we definitely recognize that's going to affect schedule. We also know that there's this lack of clarity around code for storing battery electric buses is going to be an issue until codes are updated, because we don't necessarily know what any different given building inspector is going to require to permit the building until there's clarity in the code. And then operationally, deploying buses at scale is going to raise a whole slew of new issues in terms of resourcing and training. And then looking ahead, well, we're expanding our purview to thinking about en route charging and thinking about how we can accommodate the space and funding for these projects, and then working with our utilities to meet massive power demands at our facilities and even these en route charging locations, while they're faced with everyone trying to electrify everything all at once. So that is all I had today, and I'm happy to answer questions.
Okay, Alexandra, thank you very much. I guess we should give her a clap. And I have a question. There's a lot of emphasis on trade studies, and to do that and probably do them quickly in a lot of variety of areas that both look at the civils and infrastructure type issues with the buildings, the systems that will be in them, managing the square foot cost. Are there any tools and models that your team uses to try to simplify that or make it easier to come up with calculations fairly easily?
That is a good question. So not necessarily to come up with like a solution to some of the cost challenges and trade-offs that I've been mentioning. I mean, we start not in terms of like a model, we definitely just use more analog, like having a space program and kind of having a single place to go through it. But I will mention that something we're trying to do is not only electrify our buses, but electrify our building systems. And so we have certainly been doing like energy modeling early on in the design to understand the full power demand for the facility side, as well as for the bus charging, so that when we go to the utility very, very early, because it's a very big load that we're anticipating. Like for Arbor Way, we went to the utility and we said, we think the peak power load will be 14 megawatts, which is a lot bigger than most buildings. And so we're trying to kind of model that as early as possible so that we can work with the utility on how they would actually, provide that power, and then how they could provide it with redundancy too, to help with resiliency. So I do think we do like energy modeling potentially earlier than you might do in other building types. But I don't have a different model that's sort of speaking to some of the other stuff that we're trying to kind of piece together and balance.
All right, thank you. Any other questions out there?
Just a thought with respect to I think it was the Quincy facility that was, struggling because the technology was kind of racing racing ahead of the design, and you've got that tension between technology development. Was there any discussion with some of the suppliers, or trying to squeeze a technology roadmap out of some of them so that they can give you, where they think they're heading, and you can maybe synchronize, your thinking in that regard, and perhaps even, look at a more modular kind of a design so that you can adapt fairly readily, maybe not completely plug and play, but somewhat that way with some of them.
Yeah, I think so. A couple of things. So I think we should probably be doing a little more of that. I think we need to make sure that we are building a performance-based specification and not locking into just one supplier to adhere to our procurement law. And because how we've been going about building the buildings is, or how we plan to go about building buildings is, we'll put the whole project out to bid, and that includes construction of the building as well as the charging infrastructure, like all the way from, the unit substations to the chargers and, pantographs and plug-in dispensers. And so we need that to comply with our procurement law. We need to use performance-based specifications. And so we can't just kind of like tailor it to one type of, very specific application. And then the other thing is, although we want to be like, I think there's a balance for all transit agencies where you want to be like not too far ahead on the cutting edge stuff so that you're the only one doing something, and then other like direction starts changing, and then you're kind of stuck with something that's too had been forward thinking and then becomes a little bit obsolete. So although I think it makes sense to talk to industry and get a sense of where things are going, we don't actually, I don't think as a transit agency, we want to be on that like cutting edge. We want to have something that's a little more tried and true, because our number one priority is getting the buses out every day, right? And so we just need to make sure that whatever we go with is going to be reliable, and then also that we're going to be able to maintain it and get all the parts we need, et cetera, for the full life of that asset. And that's something that I think we're all kind of dealing with like a challenge on. But I definitely appreciate the idea to kind of think like more modularly and potentially even kind of think differently about splitting up the procurement of the chargers from the building as we move forward, so that we have a little more control over it. Because right now it's sort of within the full contract package for like the general contractor that's building the whole building. Does that make sense?
Yeah.
Does that answer?
Yeah, no, it does. Thank you. Yeah, because I was thinking in terms of, to protect the agency, building in some of the some sort of a modularity set of requirements.
Yeah. And we want
so,
like as much interoperability, and
Yeah, no, that sounds good. The other thing, if I could sneak in a second question, are you guys, if you're working with, I think in terms of the ISA, like the independent safety assessor, but any of those sort of regulatory oversight folks that would be involved in the project, so you can, actually turn it on and use it at the end of the day. Are you working with them kind of at the very, for the full life cycle? So they're kind of brought in, and even though the regulations are a bit, shall we say, vaporous right now, they're not finalized, but are you kind of having that shoulder to shoulder or over the
with
shoulder
like the building inspector?
Yeah, from the very beginning, even early design phases.
Yeah, we actually have started inviting them to all of our milestone reviews, I believe.
Oh, perfect.
We then generally by like the end of design development have like a one-on-one with them, and to make sure they're okay with the project before the contractors actually trying to get a building permit from them. That's fine. Which is typically how, like, so we'll, kind of review the design with them, answer questions, incorporate comments, and then And then typically it'll be actually on the contractor to like submit the drawings to the building inspector and get the permit. And then, there'll be the inspection, all that stuff. And so to avoid surprises. But I think in Massachusetts, we'll have a different building inspector for every, I think it's about for every municipality, and the MBTA covers like 150 municipalities. We don't have best facilities in all of them, obviously, but it just means that since there's not clear direction in the code, like it's really at the discretion of, well, it's unclear whose responsibility it is to come up with guidance on how to address fire suppression. Ideally, I think it would be the chief building inspector at the state level to kind of come up with an interim solution until like NFPA has something clearer. I hope that also answered your question.
Yeah, no, yeah, thank you. Yeah, and thanks for your presentation. I'll turn it over so others can get some questions in.
I can probably ask one here. Sergio from Vancouver in Canada. So, Alexandra, you mentioned about maybe contracting with, like you having like a contractor for the building and the charging infrastructure, but have you thought of maybe integrating something related to charge management system or right away, or do you have anything in mind? Have you explored any options?
Yes. Yeah. Thank you for asking that. That is going to be, that's also part of the building package, basically. Like it would need to be, it's part of the specifications, and it's going to be critical for us. That is the reason we're able, we're banking on charge management as the reason we're able to kind of optimize the total power load by spreading out the charging overnight, not having most of our buses come back around, starting at 8 p.m. to midnight. But if they all just got on a charger and charged right away, like we'd have a huge peak at 10 p.m. It would just be unworkable from a power supply. Not unworkable, but it would be much more expensive because we have to pay for obviously the upgrade, the service upgrade for these sites. So yeah, charge management is going to be really important for us. We do want like a solution that works for us in terms of allowing us to smooth out those peaks of charging, but still meet service needs. So I guess it'll have to talk to like knowing the bus blocks, and then be a tool that our maintenance folks and bus operations folks can use to know, which buses are ready for service the next day, what blocks are the best blocks for them. But we don't want it to be too, like, I would hope that we can have something that's as simple as possible so that it's not too like tailored or overcomplicated. And then, I think like the goal is simplicity with this stuff to ease any hiccups in the transition. So yeah, good question. I forgot to talk about charge management. We learned about what's out in the industry last year through an RFI, and that was really insightful. And yeah, we're looking forward to kind of seeing those systems deployed in action. Hopefully they work.
Yep, thanks. Appreciate your comments.
All right, we got 10 more minutes. Any questions?
Oh, sorry, Mike.
Oh, go ahead, get it.
Yeah, I don't want to hog the microphone here or anything, but just a sort of a general question. If you could maybe just kind of sort of set the stage for folks that aren't as familiar with MBTA, like as far as their the culture, as far as systems thinking, systems engineering kind of where do you feel you're at in that kind of maturity, without losing your job?
Well, I mean, I'm not sure I'm the best person to answer that question because I had to ask Pokey what systems engineering was because I'm a
Oh,
planner.
okay. Okay.
So, I mean, in terms of problem solving, or yeah, I guess.
Like, is there a general acknowledgement? Because, there's always the confusion, right, with the definition. Even the word systems can be problematic. And of course, the word engineering can be problematic too, depending on how it's being used or abused. But the concept of, systems engineering in sort of the construction world is really just a short form of saying subsystems, which could be, any of the building subsystems like HVAC or power, that sort of thing, as opposed to the INCOSE, life cycle viewpoint, which is, probably, more aligned with, in a way, with kind of the asset management, the transit asset management viewpoint of looking at a life cycle. I know you mentioned life cycle cost on one of your slides. So I just wondered if there's kind of an awareness, or is that
Oh
still...
yeah, then yes, definitely. I think we actually, I mean, with any legacy transit system, you are running up against like kind of systems that have been in place and like adapted over time to a world of reduced or inadequate resources for maintenance, for operations, and then like varying priorities and kind of based on political winds. And so you find where there's like a huge challenge where people have just sort of adapted their processes to just making it work. And then you take a step back and you're like, oh wait, this is creating a whole new set of challenges, or this isn't how we might go about it if we were like starting from scratch today. And then there's just like frankly, like an uncertainty about like everything we have out there. I mean, we have a huge network. We have rail, but then we have commuter rail. We have 400 miles of it. We have tons of stations on that. We have a bus system that serves, I think it's 100 times, a lot of towns and cities in Massachusetts. But given that, I think since we had a lot of challenges in the winter of 2015, where we had these huge snowstorms, it just made the subway system like not be able to run very well. That kind of like opened up a lot of discussion about how we kind of want to rebuild back up like asset management. And I think taking this more like systems approach to parsing through both like our capital needs and just operationally. And so we've built up a big asset management team that's taking like a very kind of rigorous look at that, at just tracking assets and condition and needs. And I think with this transition to battery electric bus, we're working on the projects to build the new facilities, but we also knew that those wouldn't be successful unless we actually set ourselves up operationally for this transition. And so we hosted a working group last spring where we talked through kind of like systematically working through almost like a service day example of like, what are all the differences that we know now that we'll have to adapt to with battery electric bus, and how can we prepare those departments to make those changes? Is it additional operating budget for something? Is it training? Is it, what? So we kind of like systematically, so to speak, went through to identify those needs. And then I think people were very much engaged, but it's hard because there's always a lot of that is like long-term thinking, and there's usually like a tomorrow problem that needs attention. So I think I'm not sure if that kind of gets at your question, but
yeah, it does. It does sound like, I spent with my time at MARTA, it was difficult to get all the stakeholders kind of involved in some of the the larger, the more strategic, as opposed to, like you say, the day-to-day just putting out fires.
Yeah.
But it sounds like,
Literal and figurative.
and one of the notorious, one of the notorious groups that sort of wasn't or didn't seem to want to get involved was the planning group, and we could never figure out, because the name of the group, is planning, right? So we're trying to figure out, why aren't they more interested in talking to some of the other stakeholders? But there was a lot of, I would say, traditional over the wall thinking that was going on, like, I've got my little fiefdom, I've got my, so I'm going to chuck this planning stuff over the wall to you, Mr. Engineer, and you figure out how to make it work. But it sounds like you have a more collaborative environment. Is it safe to say, or?
Yeah, I mean, I think yeah, it's, I think there's always going to be challenges in like a resource constrained environment to sort of to getting there. But I certainly think, like, for us, part of the reason they brought in two urban planners to stand up this program was because we really focus on that stakeholder engagement. And so we've built up a really good relationship with the folks who will be, I mean, I hope really good relationship with the folks who will be using these facilities. And that's sort of like kind of the linchpin of how we're approaching it.
Yeah, that's fantastic. Well, thank you. Yeah, that definitely answered my question. I appreciate it.
Alexandra, I have a question real quick on the initiatives that you're doing for electrification. I mean, they're not done in isolation. I assume the city of Boston is trying to do this, and the power, is it integrated with the other initiatives within the region? How's that work?
Oh my gosh, this is my favorite topic. Like, I wish. I keep saying, like, it's really hard because it's a capital expense for us to upgrade the power at these sites where we're building new facilities. The utility passes that on to us, and they might deduct some assumption of that we'll be a ratepayer with a bigger load. But I think it's still I think it's still something that would need to be tackled, like, regionally, but it's really hard because everyone has their own challenges and initiatives, and a lot of the power supply upgrade that I feel like would be needed is just to serve a lot of individual homes. And so I'm not fully aware of like other things going on at the state level. But I agree that, there's like a need for more coordination to sort of look at, and I think the utilities do have like systems engineers that are looking explicitly at this, but kind of what is the regional demand projected, and how can we get there in a way that like everyone's paying their fair share, but we're not doing it like one-off project at a time. I think that's more kind of like in the utilities boat to look at. I think they're looking at it, but I'm sure we'd be happy to kind of participate in like a conversation like that. The MBTA it's actually not like part of the city of Boston government. It's part, I don't know how familiar you are, but it's because it serves many different cities and towns. It's more state level.
Yeah. All right, thank you. We have a minute. Is there anybody else with a question?
Yeah, I figure my mic was out, but yeah, we actually is at time. So yeah, we can. If anyone has one more question, then we can feel free to jump in. Give 10 seconds to anyone. If not, then yeah, I have shared the email. Alexandra's email before, and this webinar will also be posted on the our INCOSE TWG YouTube channel. So yeah, well, thank you again, Alexandra. Very informative, and also now you know what systems engineering is, and this more than just engineering, more than just systems. It's a lot of things, the scenarios, the life cycle, training, and we cover, start from business case, start to end, and it goes, goes around again. Yeah, it never stops. So, well, thank you, and well, we'll see you probably in December. We hope, and yeah, we would supposed to do it every month, and yeah, we'll finalize the topic, and we will share through our usual medium. So yeah, thank you, and I'll stop the recording now.